On June 2, 2025, Mount Etna unleashed its most terrifying eruption. But what surged from the crater wasn't lava. Scientists confirmed. Not basalt, not andesite, no known volcanic substance. Within minutes, an electric blue plume soared 6,500 meters high, forcing Sicily's airspace into emergency orange alert. This isn't just another volcanic blast. Etna has erupted 14 times since March, but never like this, in 500,000 years. So what did the world's most restless volcano release into the sky? And what does it mean for everyone living in its shadow? At exactly 10:03 a.m., Mount Etna's summit exploded with a force that stunned even veteran volcanologists. Instead of the familiar red-orange of molten rock, the crater blazed with electric blue light, so bright it seemed unnatural against the morning sky. Drones circling the rim captured the scene. A shimmering blue-white glow pouring from fresh fractures, casting sharp shadows across the ash. On the ground, scientists scrambled for samples, shouting over the roar of the plume. The first field reports came in within minutes. The material wasn't basalt, nor andesite. Portable spectrometers offered no match to any known volcanic glass or mineral. Lab teams, scanning the initial fragments, found nothing resembling the profiles logged in global igneous databases. The eruption's color, its energy, its refusal to fit any established category. Each detail left experts grasping for explanations. Etna had always been unpredictable, but this was something new, something no one had seen from Earth's crust. The mountain's message arrived in a spectrum no textbook could predict, and the mystery only deepened as the blue light spread across the summit. Rising more than 3,300 meters above the Sicilian plain, Mount Etna has watched over the island for 500,000 years. Its flanks are lined with the remnants of ancient forests, villages rebuilt again and again, and the bones of empires. Roman chroniclers once wrote of Etna's power not as myth, but as hard fact. In 396 BC, a Carthaginian army advancing on Greek-held Syracuse was brought to a halt, not by soldiers, but by a wall of molten rock pouring from Etna's slopes. For centuries, the mountain's eruptions shaped the fate of cities, carved valleys, and fed legends of gods and monsters. Most years, Etna's activity followed a rhythm. Bursts of lava, rivers of fire, ash drifting over Catania. Residents and scientists alike learned to read its moods, tracking patterns that, while dangerous, felt familiar. The volcano's presence was both threat and promise. Its eruptions a force woven into the daily life and history of Sicily. Against this backdrop of cycles and memory, the events of June 2025 arrived as a break from everything that had come before. At 10:03 a.m., a signal raced across Europe's monitoring networks. The Sentinel-5P satellite, orbiting high above Sicily, registered a sulfur dioxide spike from Mount Etna that dwarfed routine emissions. Data streams showed the plume had blasted to 6,500 meters, over 21,000 feet, cutting a column through the atmosphere visible from space. This was not a localized event. Copernicus data flagged the anomaly within minutes, and aviation protocols snapped into place. Air traffic control in Catania shifted to orange alert, grounding flights and rerouting airspace around the mountain. Automated hazard systems echoed the warning across the continent. This was the 14th eruption since March, a pace unseen in decades. Each episode had strained monitoring teams, but none had triggered such a sudden operational response. The numbers left no room for doubt. Sulfur dioxide concentrations far exceeded historical baselines, and the plume's altitude posed a direct risk to aviation corridors. As satellites continued to track the expanding cloud, the true scale of Etna's eruption became clear. Not just a Sicilian crisis, but a global atmospheric event now traced in real time from orbit. A wall of fire and ash tore down Etna's southeastern slope at a speed that left even seasoned volcanologists stunned. The pyroclastic surge clocked in at nearly 140 kilometers per hour, a torrent of superheated gas and pulverized rock that outpaced anything seen on the mountain in recent memory. Temperatures in the core of the flow soared beyond those measured during the notorious 2002 event, hot enough to incinerate brush, melt plastic, and scorch the ground to a glassy black. Sensors along the Valle del Bove registered the thermal spike in real time, warning teams that any living thing caught in the path would have had no chance to escape. The surge carved a fresh scar into the landscape, stripping away vegetation and leaving behind a smoking, sterile channel. Compared to the 2002 surge, which nearly reached inhabited zones before losing momentum, this flow moved faster, burned hotter, and left less room for error. For scientists and civil protection crews, the numbers told a simple story. Etna's hazard profile had changed. The need to reach the crater and secure a sample before the new material cooled was no longer just a scientific priority. It was a race against a force that had already rewritten the rules of engagement on the mountain. Dr. Alessio Romano's team reached the southeast crater just under 2 hours after the initial blast. The landscape was raw, a field of blackened ash, the ground still radiating heat from the surge that had torn through minutes earlier. Static clung to every surface. Hair stood on end beneath helmets, and the air snapped with invisible charge, thick with the bite of sulfur. Each breath burned. Equipment faltered in the electromagnetic haze. Drones, meant to scout ahead, lost signal mid-flight and tumbled from the sky, their feeds freezing in static before impact. Radios crackled and died, leaving only short-range hand signals and shouts muffled by respirators. The field team pressed on, boots crunching over ground that shimmered with a faint blue glow. Every step was a calculation. How close to the edge? How long to linger before the heat and fumes overwhelmed the filters? Their mission was clear: retrieve a sample of the glowing material before it cooled, before the mystery faded into the ash. The window was closing fast. Romano and his colleagues worked in a world stripped to essentials: sight, touch, the weight of tools, and the knowledge that whatever they brought back might be the first real clue to what Etna had unleashed. No one spoke of danger. The mountain dictated the terms, and the team moved, driven by a mix of training, urgency, and the hope that the impossible could be captured by human hands. A single drone, battered by static and ash, managed to transmit exactly 12 seconds of footage before vanishing into the blue-lit plume. For days, technicians at INGV worked frame by frame, salvaging what they could from the corrupted data. The recovered segment begins with a jolt, then steadies, revealing two distinct channels of electric blue light racing side by side across the crater floor. The usual reds and oranges of molten rock are absent. Instead, the flows pulse with a blue so vivid it reflects off the settling ash, casting ghostly patterns that ripple and fade. Telemetry logs show the drone's sensors spiked as it approached the channels, registering electromagnetic interference far above background. Each second is jagged, the image breaking and reforming as the drone fights for signal. In the final frames, the channels split and arc apart, leaving a trail of blue-white afterglow. Then, static. The drone's feed cuts out. Its last data packet time-stamped at 12 seconds. For scientists, the footage is irrefutable. Whatever erupted from Etna that morning, it was not lava. The video became the primary evidence, proof that the anomaly was real, not a trick of the light or artifact of failing equipment. With the world watching, the need for a physical sample shifted from urgent to absolute. The sample left Etna's crater sealed in a nitrogen canister, its blue glow still pulsing behind the reinforced glass. Dr. Alessio Romano carried it himself, boots grinding through the ash as he made his way to the landing zone. The chain of custody log began at the crater rim, each entry signed and time-stamped, first by Romano, then by the field technician, then the helicopter pilot. The canister never left their sight. Within minutes, the team boarded a police helicopter, rotors slicing the sulfur haze as armed officers checked the perimeter. The flight to Catania was short but silent. The canister strapped beneath Romano's seat, guarded by 2 officers in flak vests. At the INGV laboratory, the transfer was recorded on video, with signatures from both the field team and lab staff. The nitrogen seal stayed intact from crater to lab, preserving the sample's volatile chemistry for analysis. Romano's words, recorded in the logbook, were clipped and direct. The most dangerous puzzle Etna has ever handed us. Every step, every signature, every locked door, measures taken to ensure that what left the mountain arrived unchanged, ready for the tests that would follow. Lab technicians at INGV Catania opened the nitrogen canister under filtered air, lights dimmed to reduce interference. The fragment inside pulsed with its own blue-white glow, visible even through the thickest safety glass. As soon as the first ultraviolet lamp swept across the sample, the stone erupted in fluorescence. Intense, unnatural, lighting up the detection chamber. Standard gamma counters, placed at a safe distance, immediately spiked. Both detectors hit their maximum readout, alarms flashing, forcing a reset. No background interference. No known volcanic rock in the reference archive had ever triggered a response like this. With the chamber resealed, a second, independent gamma probe was brought in, calibrated against certified standards. The spike repeated, exactly matching the first. Instrument logs ruled out contamination or malfunction. In a final check, a third detector, borrowed from the radiological suite, confirmed the off-scale readings, each time the sample's glow intensifying under UV. Every result was logged, time-stamped, and witnessed. The lab's spectral data showed a signature outside anything in the terrestrial volcanic record. The anomaly was reproducible, undeniable, and impossible to explain with the tools and knowledge on hand. The question was no longer whether the sample was extraordinary, but what could possibly account for its behavior. Inside the Catania lab, the sample faced a test that no volcanic rock had ever failed. Technicians raised the induction furnace above 1,600 degrees Celsius, well past the melting point of basalt or andesite. Still, the fragment sat unchanged, its surface untouched by the heat. Instead of softening, it responded with something no one expected. Blue-white arcs leapt across the stone, flickering like contained lightning beneath the quartz window. Instruments recorded electrical surges with every pulse. The team watched as the arcs intensified. Then suddenly, a hairline crack split the containment seal. Blue vapor hissed into the chamber, tripping alarms and forcing an emergency lockdown. Automated doors sealed the lab as air scrubbers whined into action. Spectrometers scanned the escaping gas and flagged rare earth elements, yttrium, cerium, and a suite of lanthanides. in concentrations far beyond what any crustal magma could explain. Dr. Lucia Pompilio reviewed the data in real time, her notes terse. "We're reading mantle-level chemistry at surface pressure." For the first time, the lab wasn't just chasing a puzzle, it was confronting a threat that standard protocols could barely contain. 3 of Europe's top laboratories weighed in on the glowing fragment from Etna, and not one result matched the others. In Catania, X-ray diffraction scans produced patterns that fit no known mineral, terrestrial or otherwise. The software flagged every peak as an outlier, and the lab's database, built from decades of volcanic samples, returned only blank fields. At the GFZ in Berlin, geochemists isolated trace elements usually locked deep in the mantle, signatures that had never surfaced in any recorded eruption. Their instruments traced rare earths and isotopic ratios that defied the expected path of magmatic evolution. Meanwhile, at the Sorbonne in Paris, Raman spectroscopy pointed to high-pressure lattice structures, the kind found in meteorite debris or synthesized under extreme laboratory conditions. Each team ran duplicate tests, cross-checked their controls, and still landed on the same impasse. The sample's identity was impossible to pin down. What began as a routine chain of custody split turned into a scholarly standoff, with every lab defending its methods and none able to explain the contradictions. The debate spilled into urgent emails and late-night calls, each new result only sharpening the sense that Etna's eruption had delivered something the textbooks couldn't explain. Beneath Etna's fractured summit, seismic arrays picked up a new pattern, waves moving slower than solid rock should allow, echoing from a zone 3 kilometers deep. Tomography models mapped this region as a low-velocity pocket, a reservoir of partial melt swelling under immense pressure. At the surface, ground stations tracked 4 centimeters of uplift on the southeast flank in just 12 days, an acceleration that left geophysicists on edge. GPS and INSAR data confirmed the deformation, lines of elevation shifting in real time across the digital terrain. The numbers stood out against decades of prior monitoring. Etna had never swelled so fast, not even before its most notorious paroxysms. In the days following the eruption, an internal INGV memo circulated quietly, warning of an unstable system and advising heightened alert for sudden changes. There was no consensus on what triggered the surge, but the signals were unmistakable. Deep within the mountain, forces were gathering, warping the crust, and feeding a pressure front that threatened to rewrite the rules of Sicilian hazard planning. The mountain's silence above masked a growing unrest below, one measured in centimeters, seconds, and the uneasy calculations of those tasked with watching for the next move. In the towns below Etna, uncertainty settled like ash. Civil defense bulletins offered no order to leave, but by afternoon, cars traced hurried paths out of Zaffarana, Etnea, and Nicolosi. Families packed essentials, unsure if the blue haze in the air meant danger or just another false alarm. Hotel lobbies emptied almost overnight. Tour bookings, once steady even during minor eruptions, collapsed by more than half in the first week. An economic blow that rippled through shops, guides, and restaurants. On the political front, 2 foreign mining companies filed requests to explore the new material, citing its potential value. The response from Sicilian officials was immediate: a sweeping ban on any extraction, calling such plans madness on sacred land. Meanwhile, Sentinel radar confirmed the southeast flank was swelling at twice the previous evacuation threshold, yet the official stance remained unchanged. No evacuation, only watchfulness. Beneath the daily routines, Tension grew, as if everyone was waiting for a signal that might never come. At 10:03 a.m. on June 2, 2025, Mount Etna produced its 14th eruption in just 3 months. But what emerged defied every volcanic record. A blue-white material, confirmed by laboratory tests to match no known terrestrial rock. European labs in Catania, Berlin, and Paris each found conflicting data. Deep mantle elements, high-pressure phases, and off-scale gamma readings, while an INGV memo quietly reclassified Etna as an unstable system. Seismic maps revealed rapid uplift and partial melt zones, echoing patterns seen before Etna's most destructive collapse 7,200 years ago. Meanwhile, over half of local tourism vanished, and residents faced mixed signals. No official evacuation, but undeniable fear. The origins and risks of the blue substance remain unclassified, with all public analyses to date inconclusive. What is clear, Etna's June eruption changed the known boundaries of Earth science and left Sicily's future under a cloud of uncertainty. The story of this volcano, and the mystery beneath its surface, is not yet finished.